Hello, class. Today will be our video on factoring, particularly factoring polynomials. This is R5 from the book. And I want to start by saying this is one of the core concepts or core content topics for Unit 1. Factoring is one of those things that it can show up randomly at any time the rest of the semester. It's fair game the whole time. Um, Unit 3, I think, is where we'll see it most after this unit, but it could pop up anywhere. So uh, the part of the problem is, and one of the reasons I'm going to spend extra time on it, is this is one of those topics that theoretically students who come into college algebra should already be comfortable with factoring. The reality is it's one of those topics that students tend to struggle with, particularly at the beginning of the semester. So it's definitely worth doing the extra review. And this is something that if you're having trouble with beyond what I'm doing with the videos and what MyMathLab is doing, you definitely want to get help sooner rather than later. Because like this is a big part of test one, not to mention it will show up later. So in fact, I'm going to split this video up into two parts. Because I think it would make it way too long if I tried to cover everything all at once. Plus, I'm a little under the weather today, so I don't know if my voice can handle doing like 2 hours worth of factoring all at once. So that's um, factoring is one of those higher level algebra skills that you need to have for college algebra, and for the handful of you that are going on, you definitely would need this in trig and calculus. So. All right, well, that said, let's get into what I want to do for this part one is we're going to talk about sort of the theory and the big picture behind factoring. Give you sort of the critical thinking aspect of what we're doing, what you need to be able to do as a student. And then we'll get into the factoring techniques themselves, which for this first part, we're going to do GCF, which is Greatest Common Factoring, and factor by grouping because those are related. The second part of the factoring video will cover trinomials, a couple of techniques we'll talk about there, as well as difference of squares, which is a pretty common technique. Right. So let's talk a little bit about the theory. And as always, for those of you that are following along at home, if you want if you want the handouts of what I am doing in Blackboard under the study resources for Unit 1, you go to the lecture note outlines, the R5 factoring view, that is where I'll be doing, I'll be grabbing all my examples from today. All right. And again, if you happen to be on campus and want to get printouts of all of these, you don't have to print them off yourself. I do make printout copies for my in-person classes. If I know you're coming, I can leave one for you outside. I have a little cubicle area outside my office. I could leave you one there, or if you can catch me in my office or in the classroom, I can give you one there. But I do think it's helpful to have these printed off ahead of time to help go through the videos. All right, so let's go to what are we talking about today? Again, you've got the student or the learning objectives. And so today we're going to be doing GCF and factor by grouping. And what does factoring mean? What do you need to be able to do for factoring to be successful? That's where we may not look like much on paper, but again, this will probably be the topic we spend the most on this unit one. Maybe one of the longer topics for the whole semester, actually. So, and for those of you that are have factored recently, then more power to you. But again, like I said, most people are going to benefit from this review, so that's why we're doing it. All right, let's talk about what is factoring. Just before you even get to factoring polynomials, what would you say if I said factor 10? Not sure what here's why. If I said factor 10, hopefully you're thinking 2 times 5. It's probably going to be the most common answer. You could say 1 times 10. That doesn't really get you a whole lot because 10 is still one of the factors. And so when we're factoring a number, you're breaking up into a product. What if I say factor 12? Well, there's a few more ways we can factor 12. Some of you might be thinking 2 times 6. Some of you might be thinking 3 times 4. But neither of these would be like the preferred answer. So like, typically you might think of like prime factorization. And the problem with these is like 6 can be broken down. 6 is 2 times 3. So 12 would actually be 2 2s and a 3. Or if you look at 3 times 4, 4 is not prime, so we can break that down. And so we could say 3, and then 4 is 2 times 2. Which either way, you have 2 2s and then a 3. Now that product gives you 12. So that would be fully factored. Now these are partially factored, these are fully factored. The reason I'm talking about this is when you're factoring polynomials, this is what you're doing, is you're trying to take a polynomial, whether it's a binomial, a trinomial, or a 4-term polynomial, and you're trying to figure out what do you multiply to give that original polynomial. So anytime we're saying factor a polynomial, your answer is always going to be something times something. Okay. And something like factor 10, there's only one answer. It's already fully simplified, but the same idea here is if I say factor polynomial and you give me this equivalent, then that means you're not going to get the right answer because you didn't finish the problem. So factoring polynomials may seem a lot messier than I'm talking about now. I mean, I know it's a lot messier, but the core idea is when you're factoring something, you want to figure out what multiplies to give you that answer. Right? And what makes this challenging is you're used to factoring with numbers like this, but now you're going to be factoring with monomials and more often binomials. So instead of having something like your prime factors being 2 and 3 and 5 and 7, now you might be looking for factors like x minus 1, x plus 2, 3x minus 8, or something like maybe x squared. Like all of these are potential factors. And so you have to take that knowledge, of factoring numbers and convert that into factoring polynomials. And so the reason that the first homework set, we're doing this second homework set, not first homework set, is this all depends on multiplying, right? So, when we say distribute, I think, the most common example is A parentheses B plus C. When I say distribute that A, and we talked about this with, your first homework set, that's why you get a lot of multiply problems. That would be A times B plus A times C. A times C. Right. So if you're going in this direction, that's a distribution problem. But what we're going to do with factoring is we're going to start with this and go backwards. So distribution and factoring are sort of the same idea, just different directions, sort of like multiply and divide. Right? They're both the same basic operation, it's just which direction you're going. So the reason that I had a lot of factor problems, or FOIL problems and distribution problems in the first homework set is that you get more comfortable, like the more comfortable you are with foiling that, the more comfortable you're going to be with taking that answer and figuring out that it came from these binomials. Okay, so that's big picture. What you're doing when you're factoring polynomials is you're taking that polynomial and figuring out what you multiply to get it, which a lot of times there's going to be binomial factors. They should sometimes be monomial factors. So that's what we mean by factor polynomial. So just some general things to think about before we actually get into the techniques. First thing you need to do is make sure your polynomial is in descending order. I say it's generally useful, but I should probably just cross that out and say, one, just put it in descending order. Because if you don't, one, our factoring techniques are all designed to work around polynomials that are in descending order. So you may not be able to use our factoring techniques if it's not in descending order. Also, if polynomial is not in descending order in a problem, very often there's a negative GCF, which we'll do some examples of that. But the way the people who write the problems hide those negative GCFs is often by putting them not in descending order. And we'll discuss that. All right, so what you have to be able to do as a student. Now, for this homework set, we're going to go through the techniques in order. But for the rest of the semester, you're going to have like a random polynomial to factor, and you're going to have to be able to look at it and figure out which technique. Okay. So this is sort of separating out, like when you first learned factoring, you were focusing more on the skills, the factoring skills themselves. Now that you're in college algebra, the higher level work that you have to do as a student is you also have to recognize which technique to use when. Okay. So that's when I talked about the theory of factoring, that's one of the things we're going to talk about quite a bit here. So when it comes to factoring, now we have 5 techniques that we're going to talk about, which back here on this sheet I listed, I got all 5 listed. So the GCF, which is the greatest common factor, factor by grouping, reverse FOIL and the AC method. Those are for trinomials, which you may have other techniques that you use for trinomials. If those techniques work for you, I don't care which technique you use as long as it's working. But in my experience, I don't think I've ever seen a technique for factoring trinomials that was not one of these 2 methods, like in a slightly different package. And sometimes one of these works better for people than others. I think it's helpful to have both of those techniques in your tool bag because it just gives you more flexibility. So that's when we do part 2 of the factoring video, that's where we're going to spend most of our time is those 2 techniques. And then the 5th technique we're going to talk about is difference of squares. So as a student, to be a successful factorer, you need to be able to recognize when to use which technique. That's how because if you don't, that means how do you get started? All right, so let's talk about that. Okay, so when you're factoring, after you put it in descending order, the polynomial in descending order, look for a GCF. Okay, that should be your first instinct. Always ask yourself: is there a GCF? If there is, factor that out first. A lot of times the factoring problem will be just a GCF. Sometimes it'll be 2 techniques, a GCF and another one. And if you don't factor out the GCF first, a lot of times you can't do the second technique, or it's just really messy and really hard, and then you end up missing the GCF anyway. So anytime you're factoring, you should always look for a GCF. Now, how do you recognize a GCF? Well, first of all, any polynomial could potentially have a greatest common factor. It could be a binomial, it could be a trinomial. Theoretically, it could be a 4-term polynomial, but generally we reserve those for factor by grouping, which is the next one we'll talk about. But just remember, any polynomial could have a greatest common factor. So you need to look for that. Some of the things I look for GCFs, for common factors. First of all, I know this isn't a math term, but the messier it is, the more likely it is to have a GCF. And I'll show you what I mean once I kind of talk through these techniques. But in particular, if it's got exponents higher than 2, there's a good chance there's a GCF. If it's got big numbers for the coefficient, it's a good chance there's a GCF. If it's got multiple variables, like an X and a Y, or like an X, Y, and a Z, I would say it's definitely going to have a GCF. The messier it is, the more likely it is to have a GCF. But that can be any polynomial, so watch out for that. Okay. The next technique that I would look for is factor by grouping. And the reason I say factor by grouping next, it can only be used if it's a 4-term polynomial. And it's sort of an extension of the GCF factoring, which is why we're covering both of those today. But factor by grouping is only for a 4-term polynomial. We don't use it as much, so it's a little bit easier to recognize, a little bit more straightforward than the trinomials. Now, if it's a 2-term, a binomial, and I often, step 3 and 4, these are what works best for you. Difference of squares, that has to be 2 terms. It has to be a binomial. It has to be something squared minus something squared. And I'll write all this down later. But then it also has to be a subtraction, not an addition. Okay. So once you get used to, once we talk about the different squares techniques, that one I think is pretty straightforward to recognize. And if it's a binomial, it can only be a GCF or a difference of squares. So those are only two techniques. And then sort of the messier factoring is if they're three terms, if they're trinomials, then you have the reverse FOIL and the AC method that we'll talk about in part 2. And again, some of you may have equivalent techniques, which is fine. But one thing, that's like the first thing you have to do is recognize like which technique is applicable. Okay, so in class, this is what I would do at this point is I would give them about 10, 15 minutes, maybe 10 minutes, and go through on this next page and say which technique are you going to use? Are you going to use GCF? Or are you going to use factor by grouping? And so on. Now, on number 5, you see the sum or difference of cubes. We're not going to use that. That doesn't get used near as often as it does difference of squares. I think we've got more than enough to keep us busy with these other techniques to not have to worry about sum or difference of cubes. If you're going on to trig and calculus, maybe want to come talk to me and I can walk you through that right quick. It's got its own pattern. It's if you can factor all the rest of it, you can factor sum and difference of squares later on if you need to. All right, so now we're going to do number 6 should have been on the next page. Is I want to take a couple minutes and we're going to go through several. We're not going to go through every single one, but we're going to go through a lot of these and try to identify which technique to use. So that's like, how do you get started? So that's sort of the key step. All right, so let's start with number 6. So all we're doing right now is identifying the technique. So one, is there a GCF? Well, when you look at number 6, 27m to the 8th plus 6m to the 5th plus 30m cubed, is there a GCF? Is there something common to all three of those? So notice that's a trinomial, but remember GCF could be any polynomial. So the first thing I see is there's an m in all of them. So there is an m in all of them, so there is definitely common factor. Now, number-wise, the numbers are, once you start getting to those double-digit numbers like 27 and 30, I would definitely also look for GCF. They're not all even because of the 27, but they can all be divisible by 3. So there's definitely a GCF number-wise there, but there's also a GCF because of the variables. And like I said, the fact that there's an exponent higher than 2, to me, this is kind of messy. So there's a GCF. Now, is there any other technique that we might use? Well, this is a trinomial because there's 3 terms. So maybe this could be reverse FOIL or AC method. That's the thing with trinomials. You don't know for sure, especially if there's a GCF. This could be just a GCF problem, or it could be a GCF problem, and you have to factor the trinomial afterwards. So what you have to get in the habit of when you factor out GCFs, what you have left, you need to see if it can factor again, and we'll talk about that. Okay. But that's a trinomial, so it could be one of those 2 methods. There's definitely GCF. All right, so look at, let's see. So look at 7 through 12, and I'll give you a couple minutes there, see if you can identify the technique. And again, if you're rusty on this, just try to make a guess. But one thing I would recommend is at least go by the number of terms. So what would you say about number 7? Well, there's an X in all of them. There's definitely a greatest common factor. Number-wise, now those are definitely getting bigger numbers. So is there a GCF? And we'll start talking about like finding GCFs. If there's a small number, check that small number first. It might be the greatest common factor, but here they're all kind of big. 35 is going to 36. So one thing you'll have to start doing is, well, like 35, that's 7 times 5. Well, 5 doesn't go into those, so that's can't be anything. What about 7? Well, 7 doesn't go into 36. So like number wise, there is no GCF, but there is a variable. They all have an X, so that's common. Plus it's a trinomial, so it might be reverse FOIL or AC method. So this is what you're going to have to do as a student, is look at that and figure out what technique to use. All right. Yeah, so let's do a couple more and then we'll do a different approach. So what about 8? Well, it's 3 terms, so it could be reverse FOIL or AC method. Is that it? Well, there's no Y in all of them, so there's not a GCF there. Now the numbers are a bit big, so look at this, and the first thing I see is they're all even. Since they're all even, we know at least 2 can go in there, so there's definitely GCF. Okay. The 2 techniques we're going to use the most this semester are our trinomial methods and GCF. So we're going to get quite a few examples on those. All right, what about number 9? M to the 12th minus Z squared. Well, there is no GCF because there's no numbers common, there's no variables common. So what other technique could we use? Let's go back to our previous page. So there's no GCF. It's 2 terms, so it's not a factor by grouping. It's not reverse FOIL AC method. So the only other possibility would be a difference of squares. Because again, we're not doing some of the techniques. So is this possibly a difference of squares? Well, it is something, there's a difference there. Now, is that something squared minus something squared? Hint, it is. We will talk about that in part 2 of our video, exactly how that works. But this one is a difference of squares. What about the next one? Well, it's a binomial. So if it's a binomial, there's only 2 possible techniques, GCF or difference of squares. Is it a difference of squares? Absolutely not, because that's a plus, not a minus. So it's not difference of squares. Is it a plus? We have cubes instead of squares. So that's another reason. Is there a GCF? Well, there's no variables here. There's no numbers here. So this is neither. This is actually a sum of cubes. So we're not going to talk about those. So that's what you have to be able to do, is like recognize which technique. All right. How about this? Of the ones I have here on the page, which ones are going to be factored by grouping? How do you recognize factor by grouping? If it's 4 terms, use factor by group. So let's see, number 12, 1, 2, 3, 4 terms. So that's a factor by grouping. Let's see, 15 is grouping. What else on this page? 24 is factor by grouping. And 19. So all of those have 4 terms. So those are all factor by grouping. Right? So once we go through the technique, then we have narrowed down exactly how we factor. What technique would you use for 11? 15z squared plus 8z minus 16. Well, I always like to look for GCF, which actually, by the way, on the rest of these, I didn't look for a GCF. And part of that is because I've seen these problems enough that I don't expect them to put a GCF in a 4-term polynomial. So I kind of don't look for it, because we kind of take care of that when we do the factor by grouping anyway. But is 11, is there a GCF there? Well, there's not a Z in that minus 16, so there's no variable common. What about numbers? If you start, I like to start with the smallest number, 8. 8 will go to 16, but 8 doesn't go to 15. Are there any? So we need to be smaller than 8 if there is a GCF. But 15 is 3 times 5, and neither 3 nor 5 go to 8. So there's no GCF on this one. But knowing that is an important skill. So this is just a trinomial. So this is reverse FOIL or AC. Good. Let's do a couple more of these, then we'll actually get into the techniques. So what about 13? 9a to the third minus 64a. Well, it's a binomial. So what does that mean? Well, so we can't use factor by grouping because it's not 4 terms. It's not reversible AC method because it's not 3 terms. So this either has to be GCF or difference squared. Well, is there a GCF? Well, there's an A in both of those. There's definitely GCF. Right. Now, is this a difference of squares? Well, you look at it, well, that's got a cube, so that's cubic, not squared. So you may think there's not a difference of squares. Even though the 9 is 3 squared and 64 is 8 squared. Well, it turns out, like after you factor out the GCF, this actually is a difference of squares. But if you don't factor out that GCF, then you can't do difference of squares. So that's why I say a lot of times there'll be 2-factor techniques. GCF is almost always the one of them. We couldn't factor this at all if we don't factor out the GCF first. Okay, we'll definitely do that example. All right. So just a couple of the random things before we actually get into techniques. When I talked about messy, I look for GCF. Like if you look at 20, 5t to the 5th minus 10t to the 4th minus 75t cubed. I look at that and I see, well, one, there's a t in all of them, plus we have a t to the 5th. So anytime you have an exponent higher than 2, there's a good shot it's a GCF. So there is definitely a t to some power in all of those. Not to mention there's a 5 in all of those. So that's a GCF problem. This is why I really like to call these messy. If you look at 25, 72, x to the 8th, y to the 7th, plus 45, x cubed, y to the 5th, plus 63, x to the 6th, y squared. That's messy because it's got big coefficients. It's got 2 variables in each term. It's got big exponents. So to me, that's a classic messy GCF problem. And the messier it is, I mean, theoretically, it's a trinomial, so it could be reverse FOIL AC method. That one, especially with 2 variables, like with all those exponents, those 2 variables, that's just a GCF problem. But theoretically, since we haven't done these yet, it could be reverse FOIL AC. And so this is what I'm going to try to train you. Like once you do the GCF, how do you know if there's another technique or not? All right. So that is, let's find me one more difference of squares, and then we'll move on to the actual techniques. Because I think there are 2. So there's two more. Right? So if you look at 21, 16x squared minus 49y squared, it's a binomial. It's a difference. And then 16 is 4 squared. Those are squareds. 49 is 7 squared. That's definitely a difference of squares. And then the other difference of squares is 27. It's a binomial. It's a difference. X squared is obviously squared. Now, people get thrown off because it's a fraction, but think about those numbers. How do you get 25? How do you get 81? Well, 25 is 5 squared. 81 is 9 squared. So that's actually also a difference of squares. Okay. So we're going to go back and look at this again after we do all our factoring techniques. So I think that will help you kind of see your growth in what we're supposed to be doing in factoring. If you haven't factored in a while, what I'm talking about now may feel a bit overwhelming. Remember, I'm trying to kind of give you a big picture sort of stuff because MyMathLab is better with the skilled progress, not so much the concepts. Okay. So let's do some GCF. And I don't have like my full notes for this are actually for my 0 level intro class. So I don't have those posted. I should probably have those printed out, but we'll just kind of wing it from here. But what we're gonna do now is we're gonna talk about greatest common factor. Which that's a bit too much to write every time, so we're gonna go GCF. So when you're factoring by greatest common factor, step one is what is the GCF? So you gotta find that GCF. Now look for numbers and variables. You're much more used to looking for GCF for numbers. Sometimes people tend to forget the variables, or sometimes people will do one or the other, not both. And so when you're looking for GCF for numbers, that is in part kind of relying on your number sense. And I'll show you how to use factor trees in a problem to do that. And then for the variables, there's kind of a shortcut for that. So let's let's see, which one do I want to do? I want to try to get well, let's just I'll make my own example and then we'll do something from book. So let's just find the GCF. I'm going to give you three terms. 45 x to the fifth, 20 x to the seventh, and 30, let's do 30 x to the third. Let's just find the GCF first. So GCF is the greatest common factor. So that's going to be the largest term that divides into all three. So when you are looking for numbers, GCFs, always start with your smallest number. Yeah, because a lot of times that is your GCF, but 20 won't go into 30. So 20 is not the GCF. And then we have to go smaller. All right. So tell me, just by looking at it, can you see the GCF between 45, 20, and 30? Well, they're not all even because of the 45, but hopefully you're noticing that they all end in 5 or 0. So let's see, is it 5? Okay, because 5 will definitely go into 20, 30, and 45. So what we have right now is a common factor, but how do we prove that it's the greatest common factor? Well, you could run through your number sense, like I said, and for smaller numbers, that's more than sufficient. If you get some bigger numbers and you're not for sure, the prime factorization, like the factor trees, can be your friend. Okay, so let's say that you think we're going to see if 5 is the greatest common factor. So what you do is for 20, like for all these numbers, do your first factor of 5. Well, 5 goes into 24 times, 5 goes into 36 times, 5 goes into 45 9 times. So there's our common factor so far of 5. So is there anything else common that's going to be in our GCF? Well, now look at what's left over. We've got a 4, a 6, and a 9. Is there anything common between 4, 6, and 9? Well, not all three, because 4 is even, 6 is even, so those both divide by 2. Can't divide 9 by 2, so 2 doesn't work. 3 goes into 6 and 9, but not into 3. So it looks to me like 5 is the only number that will go into all three, so it is the GCF. Now, if you want to prove it, go all the way down. 4 is 2 times 2, 5, and then 6 is 2 times 3, and 9 is 3 times 3. Which I know most of you have probably been taught, like once you get a prime number, you don't have to keep bringing it down, but every row should multiply to give you the original number, and that way I don't lose it. And so what do we have common? They all have a 5, which we expected. But there's nothing else common because there's 2 2s. There's a 2 there, but there's another 2 there, so 3. So the GCF is the product of those common factors. So for example, let's say this was 60 instead of 45. Well, then there would have been a 2 in there because 60 is even. And so then they all would have had a 5 and a 2, and then 10 would have been the greatest common factor. So, number wise, go through kind of your mental multiplication, see what you think the largest number is. If you're not for sure, then do your factor trees for that number and see what you have left over to see if there's anything more to that greatest common factor. Okay. So what about the variables? Okay. Now, we don't do, for the factor trees, we tend to not do that with variables. We tend to write them out sideways. I'm going to do this the long way the first time, then I'll show you the shortcut. Well, what does x mean? X to the fifth means x times itself 5 times. X to the seventh means x times itself 7 times. And then x third means x times itself 3 times. So what is common to all of those? Well, we have 3 x's that are common. So they all have at least 3's. These have more than 3 x's. This one, but this one only has 3. So our GCF is the number part and the variable part. So 5x cubed is the largest term that will divide into 45x to the fifth, and 20x to the seventh, and 30x cubed. Okay. And so the shortcut here on the variables is once you have that common variable, which they all have x, look for the smallest exponent. All right, so in this case, we had a 3, and a 7, and a 5, so 3 is the smallest. They all had at least 3. That's why x cubed is our GCF. Don't forget, if you have a variable without an exponent, there is a 1, so you want to put that 1 there. Right. Now, let's say that there was no x cubed. Right? Go ahead, camera. Let's say that last term was just 30. What would the GCF be? Well, now the GCF would be just 5 because there is no x in all 3 of them. All right. So if you're looking for just, that's how you find the greatest common factor. Right? You kind of have to use your number sense or maybe use your factor trees to help you with the number part of the GCF. And then for the variables, if you have a common variable, look for that smallest exponent. Okay, but you're not going to just find the GCF. You're actually need to factor out the GCF, which is what we're really doing, not just finding it. But that's step 1 is find the GCF. And step 2 is you're going to divide every term in the polynomial by the GCF. Okay, so every single one has to get divided by the GCF. This is going to be our quotient. This is going to be our remainder, to a division problem. And then how that helps us is our third step, our answer. Now remember, if you are factoring a polynomial, your answer is always something times something. And so your answer is going to be the GCF times that quotient, or those leftover parts that you had from the division. And I'll also show you sort of a different way to do the division, but if you're factoring GCF, it's always the GCF times what's left over. And I really wish the habit would be to put the GCF in parentheses, but mathematicians were a bit lazy in our notation, so we know that that's something times the quotient. Excuse me. So we don't tend to put it in parentheses. I think it would help if we had that habit though. All right. So let's see what I mean by this. All right. Yeah, so let's go back to number 6. Okay, so number 6 was factor 27m to the 8th plus 6m to the 5th plus 30m cubed. So we said there's definitely a GCF. So step 1, we're going to find the GCF. All right, so what number goes into all of those? Or what number and what variable? Well, start with 6. 6 does go into 30, but 6 doesn't go to 27. All right, so we need something smaller than 6 that goes into all three. Well, 6 is even, so that'll go to 30, but again, 2 won't go into 27. But 6 is 2 times 3. So we know 3 goes into 6, 3 goes into 30, and 3 goes into 27 because it's 3 times 9. And if you're not for sure you have the GCF and don't want to do the factor tree, I'll show you again how we can check this once we get our answer. Okay, so number-wise, 3 goes into all of them. Now, variable-wise, they all have m's. So there's going to be an m in the GCF. Now, what exponent do we use? Well, if you're saying the 3, because the 3 is the smallest exponent. So our GCF is 3m to the third. Okay, so that's step 1. We found the GCF. Step 2 is we're going to divide every term in the polynomial by the GCF. That's going to give us our quotient. So what we're going to do is we're going to take 27m to the 8th divided by 3m cubed plus 6m to the 5th divided by 3m cubed plus 30m cubed divided by 3m cubed. Again, this is one of those places where like how much you need to review is varies from person to person. So how do you do this multiplication? Which when we did the polynomial work, we multiplied variables. And so when you multiplied variables, you added the exponents. So what do we do when we are dividing variables? Now you subtract the exponents. And you always subtract the top minus the bottom. Now 27 divided by 9, or by 3 is 9. M to the 8th divided by m cubed. For the notes, I'm going to write that out. So we're doing 8 minus 3, 9m to the 5th. Now for the next one, 6 divided by 3 is 2. M to the 5th divided by m cubed. We're doing 5 minus 3, or m squared. And then for the last one, 30 divided by 3 is 10. Now what is m cubed divided by m cubed? If we're doing the quotient rule, we're doing 3 minus 3. That'd be m to the 0. Now, what is m to the 0 mean? Remember, anything to the 0 power is 1. So that would be just plus 10. Or another way that you can think about it, what's anything about, what m cubed divided by m cubed? That's 1, just like 6 divided by 6 is 1. Or x divided by x is 1. Okay. So this is the leftovers of the quotient. So how do we factor this out? Well, the answer is always the GCF times your quotient or what you have left. So our answer, first part, is 3m cubed. So that's our GCF, times what's left over, 9m to the 5th plus 2m squared plus 10. All right, so a couple of comments on this. So first of all, how do you check your answer? Well, you check your answer, what's the opposite of factoring? Opposite of factoring is multiplying your distribution. So you can check this right quick. Well, 3 times 9 gives us 27, which is good. And then m to the 3rd times m to the 5th. We add those to get m to the 8th. Yes, that gives us the first term. We do 3m cubed times 2m squared. That gives us 6m to the 5th, which is our middle term. And then 3m cubed times positive 10, that does give us the plus 30m cubed. Okay, so you can check any factoring problem by multiplying it back out. Now, how do we know that this is done or that we got the right GCF? That's something you should train yourself to do, is look and see if you're actually done. And so first of all, is inside here, is there any GCF left? Well, there's not a variable in all of them, so we're good there. If you look at the numbers, smallest one's 2, 2 does not go into 9. So there is no GCF there. So we didn't miss GCF out here. If you missed something in here that's still common, that means your GCF wasn't big enough. My recommendation is to redo your GCF and then redo the division. That's going to be quicker than trying to fix it down here. Also, if you're doing this part of the division and you get a negative exponent, that means your GCF was too big on your variables. So like if I had, say, m to the fourth as my GCF, when I got down here, m to the third divided by m to the fourth, well, 3 minus 4 gives me -1. So if you're looking for GCFs, you should not have negative exponents. It means your GCF is too big here. The other thing to look for is, can we factor a second technique? And so when I look at this, what I look for, if your biggest one is m squared or x squared or y squared, there's a good chance you have to factor again. If this is higher than 2, you're pretty much done with the problems we're giving you. So since that's m to the fifth, that's not going to factor by any of our other techniques. So that is our answer. Okay. So that is a pretty straightforward GCF problem. All right. And again, if you have questions that you can't get answered through this video, please write them down and email them to me. And so we can go over them that way. All right. Let's do one that has some negatives in it. Okay, so we're going to do 20. We have 5t to the fifth minus 10t to the fourth minus 75t cubed. All right, so again, we're factoring this. So our answer is going to be something times something. And so when I look at this, there's definitely GCF because they all have a t. If I look at the numbers, they all have a 5. So we're definitely doing a GCF factoring here. So what is the GCF? Well, always start with your smallest number, 5. 5 goes into 10, 5 goes into 75. So that's number-wise, it's 5. There's a t in all of them. Sorry. And then I probably should vary these examples up, but just 3 is the smallest exponent again. That just coincidence. I didn't vary my examples enough, but that's the GCF. All right, now at this point, you could do the division on each one. I want to show you kind of how I do the division process and then kind of let you see which way might work better for you. If you haven't done this in a while, definitely write all this out at the beginning, but hopefully as you get more comfortable with it, maybe you can streamline the process a little bit. So our answer, part of our answer is 5t cubed because that's our GCF. And again, we don't normally put that in parentheses. I kind of wish we did. All right. So the first, we have 3 terms here, so I need 3 terms inside that parenthesis. So what I do is here's how I do the division. 5 divided by 5 is 1. And then I need 5 t's. I have 3. So how many more do I need? I need 2. So basically what I'm doing is kind of doing, instead of 5 divided by 5 is 1. Now instead of physically subtracting 5 minus 3, notice how I said I need 5 t's, I have 3. How many more do I need? Well, I'm still doing the subtraction. I'm just not doing it in this format, if that makes sense. All right, so now we need the next term. Now the next term is negative. And so -10 divided by 5 is -2. I need 4 t's. I have 3, so I need 1 more. Or if you want to write it out, -10 divided by 5 is -2. 4 minus 3 gives me 10 to the first. And then for the last one, minus 75 divided by 5. Remember, calculators are your friends, so don't feel bashful about grabbing a calculator. That gives me -15. Okay, now what about the t's? I need 3 t's. I have 3 t's. So how many more do I need? None. That's just -15. Or if you look at it this way, Well, it's t cubed divided by t cubed. They cancel out. So there's no t's left. Now, a couple things on the what I would put in MyMathLab. Whether you want to put parentheses or not, MyMathLab's not gonna count that wrong. That one coefficient, we tend to not put that in the final answer. That's usually something we kind of carry in the middle. Same with that one exponent. We don't tend to put the exponent of one. MyMathLab should accept that, but this is a little bit more streamlined. All right. So that is a GCF problem. Now, something to point out. Can we factor that again? Well, it is a trinomial, and now this is it's t squared. It has t squared, t, and the constant. So there's a good chance this one will factor. And I'll tell you now that in the homework, that the R5 homework is set up. It's like it's like the GCF factoring technique problems. It's the factor by grouping problems. Then it's a bunch of trinomial problems. And then you get into the ones and maybe the different squares next, or at the end of trinomials, you'll start seeing these that have GCF and a trinomial. So these will be towards the end of the homework. And then I think they always say factor completely, or they may give you some other sign in MyMathLab that they're kind of messy. But like the messier ones are like towards the end of the homework. Now on the test, I kind of when I write the test, I kind of put it in the same order. So like you're on the test, there's gonna be 5 or 6 factoring problems on this unit 1 test. Like, don't be surprised if the last one has GCF and a different technique. All right, but that's something that I would definitely look at because of that t squared. This is a trinomial that most likely factors again. But since we haven't talked about how to factor trinomials, that'll be tomorrow's or the next part 2 video. All right. Let's go through one more GCF problem, and then we'll move on to factor vectors. So here's one of my favorite, 25. So this is kind of definitely a messy version of this. We're doing 72 x to the 8th, y to the 7th, plus 45 x cubed, y to the 5th, plus 63 x to the 6th, y squared. Okay. All right. There's definitely a GCF because you got all of them have x's, all of them have y's. So let's look for that GCF. All right, here's number wise. What is the GCF? Well, here, starting with the biggest, smallest one, really not help. It's 45. They're all kind of big, so we have to start breaking it down. I think 45 and 63 are a little bit more unique. I know 63 is 9 times 7. So off to the side here. So once I factor one of them, well, I have a 9. 9 goes in 45, but it doesn't go into 72. But what about the 7? No, okay, so let's see. 45 is 9 times 5. Okay, but what do we do with 7? So there is a 9 in both of them. 7 or 5 doesn't work. 9 doesn't work because 9 times 8. Oh wait. Yeah. So when in doubt, your calculator. It is, you may hear like you shouldn't be using your calculator, but we're focusing on higher level stuff. And obviously sometimes, even in my brain, sometimes the arithmetic leaves me a little bit. 8. So if you notice, all of them have a 9 factor in them. And then what do you have left? We have a 7, a 5, and an 8. Well, there's nothing common there because 5 and 7 are prime. They're not going to go into each other. That's all they have, so it's just a 9. Now, if I couldn't have found the 9, if my brain really locked up on me there, then you kind of have to go back to your prime. So like your prime list is 2, 3, 5, 7, 11. Usually by the time you get through those, you'll have found like a starting point. And so since 2 doesn't go into those two, I would have done factor trees starting with 3, and then eventually there would have been 2 3s in all of these, and so I would have got my 9 that way. So it's, unless you go back to the factor trees, there's, again, we're kind of relying on your number sense, but when in doubt, make a guess, use your calculator, see if you get it. If not, do your full time factorization. Okay. So what about x's? There is an x in all of them. So what is the GCF for the x? Well, there's an 8, a 3, and a 6. The 3 is the smallest. And then there's a y in all of them, so we need a y. And 2 is the smallest. And again, remember, if you have a variable without an exponent, it's understood to be 1. You may want to put that 1 there to remind yourself. Okay. Now, again, at this point, if you need to physically write out the physical division, do each one of these divided by 9x cubed y squared, then by all means do so. Right. I'm a big believer in writing extra steps down is going to get you fewer mistakes than doing it all in your head. But in the interest of time, I'm going to kind of do the shorter version of the division. Show you, because again, like once you get some practice, you can do it that way. Okay, so there's our GCF. Now we have 3 terms. Okay, so we need 3 terms in our trinomial, or in our parentheses. So 72 divided by 9, I now know is 8. Okay. Now how many x's do we need? Well, we need 8, we have 3, so 8 minus 3 is 5 x's. What about the y's? I need 7, I only have 2, so 7 minus 2 is 5. Now these are all plus, so 45 divided by 9 is 5. Now what about the x's? I need 3 x's, I have 3 x's, so I don't need any more, or x cubed divided by x cubed is 1, so there's not going to be an x in this middle term. Now what about the y's? I've got y to the 5th, and divided by y squared, where I need 5 y's, I have 2. 5 minus 2 gives me y cubed. And then for the third term, 63 divided by 9 is 7. X to the 6, and I have 3, so 6 minus 3 gives me x cubed. For the y's, I have 2 y's. I need 2 y's, I have 2 y's, so there's no more y's. Sometimes your GCF will be one of your terms. So for example, let's say this last term was 9x cubed y squared. What goes here? Well, you would put a 1 there because, let's say that was 9x cubed y squared for the last term. Well, 9x cubed y squared divided by 9x cubed y squared is plus 1, so you would need a plus 1 there because there's 3 terms here, so it has to be 3 terms here. Now, are we done? Well, look inside. Is there a GCF that we missed? 8, 5, and 7, so we didn't miss a number GCF. Variable-wise, only these 2 have x's, only these 2 have y's, so we didn't miss anything there. Can this factor again? These exponents are bigger than 2, so no, that is our answer. So other than potential negatives, that's as messy as GCF is going to get. All right. Which I think once I bring up MyMathLab, we'll get some negatives involved in there. I can show you. All right, so that's a quick overview of factor by grouping, of GCF. So now let's look at factor by grouping, which is 4-term polynomials. Okay, so the general technique for factor by grouping. Lead through on this. All right, so first of all, it must be for term polynomial. It's the only time you're going to use it. Now, when we get to trinomials in part 2 and talk about the AC method, one of the major steps in the AC method is taking that trinomial and turning it into a four-term polynomial. So if you like factor by grouping, then you probably tend to be in that group that also uses AC method a little bit more. There's fun. So we could turn trinomials into four-term polynomials, but we have to do a little work, and that's video number 2. All right, so that's what you're looking for first. And so to do factor by grouping, okay, is you're going to group the first pair and last pair. Now, what I mean by that is, like, if you look at number 12, and we're going to walk through this one. So the first pair is 30x squared plus 12x. Now, I know that vast majority of the time this gets taught, you get taught to put parentheses around those. I don't like that because then if you have parentheses here and here, then it tends to look like a fuller problem. Plus, we tend to lose that middle sign. So I like to underline them. That's a bit of a pet peeve of mine that it's taught to put parentheses around those because, like I said, that middle sign so often gets lost. But the first thing you do is we're just looking at the first pair and separate pair, and the reason we're looking at the pairs is group the first and last pairs and do a GCF problem. Do 2 GCF factors. So on that first pair, we're going to factor out a GCF. On that second pair, we're going to factor out a GCF. Okay, that's why I say this is related to the AC method. Once you do that, and that's where you have to be careful, particularly in that second pair, and if there's a negative involved, and so that tends to cause some problems. But that's where the bulk of the work is. The second step is compare inside the parentheses. And what I mean by that is when you're doing a GCF problem, that second part, the remainder, sorry, we always put that remainder in parentheses. That's the parentheses I'm talking about once we do our GCF. And I'll explicitly show you that when we're doing examples. But for that second part, compare inside there. So here's the thing: if it's the same, then you proceed to the answer. If not the same, you stop and figure out why. Because if what's inside those parentheses after you've done your GCF factoring is not the same, either one, this is not a factor by grouping problem, or two, most commonly, since we're only giving you a few of these, then you made a mistake somewhere in your factor by grouping or in your GCF part of it. And most of the time, that's because of a negative sign. I'll definitely show you examples of that. Okay, but if it's not the same inside parentheses, stop because something is wrong. But once it is the same, then you go straight to your answer. Now remember, your answer, we're factoring polynomial, so it's always something times something. Now these are going to be binomials. So we're going to have the same thing with trinomials, but when you're factoring by grouping, your answer is always be 2 binomials. All right, so one of your binomials is inside the parentheses. So what we talked about here being the same, that's going to be half your answer. And then the other binomial is outside. Excuse me. And so that outside stuff is, since we're doing GCF, remember how we talked about I kind of said I wish we'd be in the habit of putting that GCF in parentheses. So that outside part is actually the GCF from the two pairs. And there'll be two of those. All right. So in a nutshell, that's what factor by grouping is. So let's definitely work through a few examples here. So back to the lecture outline 30, or sorry, 12 is the first factor by grouping. So we're going to factor 30x squared plus 12x minus 25x minus 10. Now, when you look at this, sometimes people look at this and say, well, the first thing I want to do is do plus 12x minus 25x and combine those, combine those like terms, which would not be incorrect mathematically. But what you've just done is you've taken that 4-term polynomial and made it into a 3-term polynomial, which means you're using a different factoring technique, which is not necessarily wrong. But if we're set up with a 4-term polynomial to start with, then generally factor by grouping is the most efficient way to go. So for factoring, you can resist that temptation to combine those like terms. So what is step 1? Is we're going to group first and last pairs. And then do 2 GCF factor. So do these as completely separate factoring problems. So what is the GCF for 30x squared plus 12x? Let's see, well, they're both even, so 2 goes into them. They're saying, 12 doesn't go to 20, or sorry, 30. So is there anything bigger than 2, less than 12 that goes into both of those? 6. 6 goes into 12, 6 goes into 30. And then variable-wise, both have x. This is x to the first, so that's what I talked about. You may want to put that 1 there. So the GCF for the first two is 6x. Then what do you have left? We'll divide both of those by 6x. Again, if it helps you to write this down, go off to the side and do this. So we're doing 30x squared divided by 6x. 30 divided by 6 is 5. X squared divided by x. Well, 2 minus 1 gives us x first, which is x. And then 12x divided by 6x. The 12 divided by 6 is 2. X divided by x is 1, so there's no x. Okay. Here's where you have to be careful on the factor by grouping, is this middle sign. This gets lost all the time. So always bring this sign down. That's going to be part of your GCF. So the GCF, like when you look at that and I say, what's the GCF of minus 25x and minus 10? If you tell me 5, you've lost that negative, which is going to completely change the problem. All right, so always bring that sign down. So if that middle sign is negative, we're actually dealing with a negative 5 GCF now instead of a positive 5. All right, so that's the GCF. Now, this first one, do I have a pencil? I want to show you the wrong way. So you may not want to write this down immediately, but what do you get when you divide both of those by 5? Well, here's what I often see. So 5x, and then you look at that and say, well, it's negative 10 divided by 5. A lot of people would say minus 2 right there. Okay. So here's the problem. These are not the same. So if they're not the same, we got to stop because something is wrong. Okay. So the problem, how do you find it? Well, distribute it back. So 6x times 5x, well, 6 times 5 is 30. X times x is x squared, so that's good. 6x times 2, that gives me plus 12x, so that's good. Negative 5 times 5x is minus 25x. But here's the problem. Negative 5 times negative 2 gives us plus 10. So the problem here is that shouldn't be minus, that should be plus. That is wrong. So if you're pulling out a negative GCF, we talked about this a little bit with the polynomials, that changes both of those signs. Right. So it was negative, negative. Now they should be positive, positive. So the right way, new red pen. So that's still 6x times 5x plus 2. Now for the second part, it's still going to be minus 5, but now it's going to be 5x plus 2, because minus 5 times plus 2 does give us the minus 10. Now we're good to go because these are the same. So when they're the same, now our answer. Okay, so we're going to have two binomials. So do your two parentheses. The first print, it doesn't matter which one's first. Some people like to, I like to do inside parentheses first. And that 5x plus 2, that's a GCF. So that is the first half of our answer. And then the second half of our answer is what is outside the parentheses. By that, I mean the 6x minus 5. Some people like the 6x minus 5 first, the 5x plus 2 second. Doesn't matter. Excuse me. Doesn't matter which one of those you have first, as long as the binomials are the right binomials. And again, how do you know this works? Well, FOIL it out. So 5x times 6x gives us 30x squared. 5x times minus 5 gives us the minus 25x. 2 times 6x is where the plus 12x comes from. And 2 times minus 5 is where the minus 10 comes from. Okay. So watch out for that middle sign being negative, because very often that leads to a mistake there. So that's why always check your factor by grouping. If these are not the same, something's wrong. And once they are the same, then what's inside parentheses is half your answer. What's outside is the other half. And again, all of this is only for four-term polynomials. All right. Again, I wish I could get your live questions. I could get it in class, but at this point, hopefully by the time we get through the examples, I'll get your questions answered. So let's do 15. Where is it? So xy minus 6yz plus 10x minus 60z. That looks messy because it has three different variables, but it's four terms, so it's a factor by grouping problem. We have xy minus 6yz plus 10x minus 60z. All right, so again, first step in factor by grouping is we're going to look at the first pair and the second pair and do a GCF problem for both. All right, so looking at just the first two, well, the only thing that's common, there's no numbers that's common. They both have a y. You plot the y. And then what do you have left if you divide both of those by y? Well, that just leaves us an x minus, and then if we pull out that y, we have a minus 6z left. Now pull down that middle sign. It's always nice when that middle sign is positive because then we don't have to worry about the negative GCF thing. So now for these last two, what do they have in common? Well, variable-wise, nothing, because one has x, one has z, but number-wise, they both have 10. So we're pulling out a positive 10 as a GCF. So we divide both of those by 10. What do we have left? Well, 10x divided by 10 is x. Minus 60z divided by 10 would be minus 6z. So are we good? So those are the same. That means we can proceed to the answer. So we're going to have two binomials. And so what are those binomials? Again, the order doesn't matter. but one is going to be inside parentheses, one's going to be outside. So inside is x minus 6z. Outside is y plus 10. There you go. Like I said, factor by grouping is one of our more straightforward factoring techniques once you get used to it. One, because it's only for four-term polynomials, and two, we don't get as messy. Like we get some messy GCF problems, we get some messy trinomials. So with factor by grouping, since it's not as common, we don't get as messy with it. But that middle sign being negative is where a lot of mistakes come in. Now there is one that you will see on rare occasions. It does throw people off. So let's do that. So if you look at 19, we have x cubed plus 2x squared plus x plus 2. Okay, again, that's a four-term polynomial. So this is your classic factor by grouping. So group the first two, group the last two. So the first two, there's no number common, but they both have an x squared. So if we divide both those by x squared, what do we have left? Well, we need three x's, so we got two, so we need one x. And then plus 2, x squared divided by x squared is 1. So x squared times x plus 2. That's how we factor the first two. Bring down the plus sign. So what's the GCF here? What is the greatest common factor for x plus 2? All right. If you look at that and say nothing, what happens in your answer? Well, what happens in your answer is you're probably just going to have x squared times x plus 2 as your answer because you're not going to have anything over here. The reason that's wrong is we need four terms. That's only going to give us two terms. So we still need a GCF. There's always going to be GCF. If you're GCF, if you're thinking it doesn't exist, what is the biggest number that divides both of those? Well, the biggest number is 1. So you will occasionally, if there is no GCF that's the same as saying 1, or if that was a minus there, that would have been minus 1. And so if you divide both of those by 1, what do you have left? Well, you have that x plus 2. So you have to have parentheses in both of these. But sometimes when that GCF's 1, this tends to get lost. Now, inside parentheses is the same. So now we go to our answer. Half the answer is x plus 2. Half the answer is x squared plus 1. And again, if you didn't have that plus 1, if you try to FOIL that back out, you're only going to get 2 terms instead of 4 originally. Now here's, so hopefully, yeah, just watch out for that. That happens occasionally. And if we're going to do that, that is, I would guarantee that's going to be in the second pair. We wouldn't put that GCF of 1 in the first pair. We just don't write the problem that way. And also, if you put it in descending order, like those first two are probably always going to have an X or a Y or whatever. So if you put in descending order, those are going to have a variable GCF. Now, one flag for me on this, that is an x squared. So the question is, does that factor again? And we're going to talk more about this with different squares, but that's a sum, not a difference. So that's not going to factor again. I'll explain that more fully when we do part 2 and we do the difference of squares factor. All right, so that is factor by grouping. That is how you factor four-term polynomials. It's really it's really 2 GCF problems in one. All right, so hopefully that helps. Now let's get into MyMathLab and see if there's anything I missed. I think there should be at least one problem with the negative in there that I want to talk about. So in the homework in MyMathLab, this is the R5 factoring review. So log back in real quick. All right, so R5 only has 22 problems, but expect this one to take you a little bit longer, particularly if you're rusty on the factoring. Let me see right quick how much we went through. Yeah, so question 8 in the homework starts with trinomials. So most of what we went through is questions 1 through 7 in the R5 homework. Okay. And so I always like to start kind of small. Oh, let me is it sharing? All right. All right. So factor the given polynomial by removing the common monomial factor. So that basically means factor, that's a GCF problem. So what's common to both of those is a 5. You divide both of those by 5, so that's your GCF. And then what's left over? Well, 5x divided by 5 is 5, plus 15 divided by 5 is 3. So that's it starts you with a basic GCF problem. Okay. Then they're going to get into messier ones. This is sort of like what was that, 25? Not quite as messy as 25, right? But oh, by the way, notice that you get an option of A, factor it, and B, it's prime. What does prime mean? I think it does this almost all of them. Doesn't do that on all of them. I need to come back to that. Well, think of it this way. What is a prime number? For example, if I said factor 13, how would you factor 13? Well, you can't because it's prime because it's just 13 times 1. And so it is possible that polynomials don't factor. There's only one specific type of polynomial that I'm going to talk about and not factoring. So that would be prime. So you should not be answering other than when we get to, I think I've already mentioned the sum of squares. There might be one specific case that's prime. Other than that, just these generic ones like this do not answer prime, particularly on the test. If you get stuck on one on the test, then show I'm big on partial credit, and we'll talk about that come test time, but show your work. Don't answer prime because the answer is not going to be that it's prime because all these factor at least a little bit. Okay, let's look at my number 3. If you're following along, your number 3 will be a little bit different number-wise, but the problem will be the same, the setup will be the same. We're going to factor negative 5x squared minus 15x. Now, look at the instructions right quick. Notice how it says factor out a -1 if the leading coefficient is negative. So they're telling you in the problem that if the leading coefficient is negative, to factor out a -1, which it's not just a -1, like whatever the GCF, it should be negative. But when we're factoring, and we got like that inside the parentheses, we don't want this leading coefficient to be negative. Sort of like we want it in descending order, and we don't want the leading coefficient to be negative. So if there is a negative in front as part of the leading coefficient, you can always factor out at least a -1 if there's not anything more. Okay, so let me go to document camera and we'll factor this one out. So there is a negative in front, so there's definitely a GCF, at least a -1, but is -1 the only thing that's a GCF? Well, no, because 5 goes into both of those, and there's an X in both of them, next to the first. So our GCF isn't just -1, or it's not just 5x, it's -5x. So what do we do with that? Well, in general, if you're factoring out a -1 or a negative GCF, that means it's going to change both of all the signs. So anything that's positive goes to negative, anything that's negative goes to positive. Just like multiplying by -1 changes all the signs. So for this one, I'm going to do the division long form again, just to help with the negatives. So you always do every term and your polynomial divided by your GCF. So we're going to do minus 5x squared divided by negative 5x. And so now those negatives will cancel. 5's will cancel. So we're doing x squared divided by x. It's just x. And then over here, negative divided by negative goes to positive. So that second term will be positive. 15 divided by 5 is 3. And then x divided by x again, that'll cancel. So it's just negative 15x divided by negative 5x is plus 3. So for our answer, well, the GCF is a negative. And what do we get when we divide both of those by the GCF? We got x plus 3. All right. So this is where, if you get in the habit of reading your instructions in MyMathLab, let me bring that up again. You know, it very often MyMathLab will give you some hints on some of these problems. So it didn't just say factor, it said factor out of -1 if there's a leading coefficient negative. So that means when you do your GCF, there should be a negative there. Other than that, this is just a GCF problem. But just watch out for that leading coefficient being negative. All right, and then you got a couple of factor by grouping problems. You know, and you know, on this one, that's that minus 2x. That means that negative, that middle sign's negative, so your GCF is going to be negative. But we did one like that, and so yeah, those are 5, 6, and 7. Those are your factor by grouping problems. So nothing fancy there. All right, and then like I said, number 8 gets in a trinomial, and my voice is starting to go. So we're gonna save that for part 2. All right. So hopefully this helps with getting you started. Again, just a quick review is when you're factoring, one of the things that you need to be able to do as a student is identify which technique that you're going to be using. Okay. So today we talked about factoring out GCFs. So remember, any polynomial could potentially have a GCF. The messier it looks, the more likely it is to have a GCF. Look for numbers and variables. You're looking for GCFs. If the leading coefficient is negative, then you will factor out a negative as part of your GCF. And then if there's 4-term polynomials, you use factor by grouping. All right. Hopefully this helps. And so I will do a part 2 of the video to talk about the trinomials and the difference of squares. Have a good day.